Time of spreadsheets is over. A Google search, a passport scan, a barcode reading in a supermarket, your online shopping history, an EKG reading, CCTV footage, a photo of a sandwich, a voice message, a tweet. All of these contain data that can be collected, analyzed, and monetized. Supercomputers and algorithms allow us to make sense of increasingly larger amounts of information in real time. In less than 10 years, CPUs are expected to reach the processing power of the human brain. A survey done by the Global Agenda Council on the Future of Software in Society shows that people expect artificial intelligence machines to be part of a company's board of directors by 2016. There is a good chance that in 15 years, your job is going to be performed by computers, since decisions once based on experience and intuition will be made through machine analysis of massive amounts of data. Think about a vehicle that is able to read its environment and react accordingly, much like a human driver, but also analyzing other sources of information that will make the trip safer, faster, and more efficient. Analyzing vast amounts of medical data from different locations and demographics will allow to determine which conditions improve the effectiveness of certain treatments and which don't. Big data analysis will reveal patterns and connections that will vastly improve most human activities. But it will also create very detailed profiles for all of us, including information that we'd rather keep private. Will big data make privacy obsolete? Or will it bring transparency, accountability, and progress?
Big data is an amazing concept. The ability to take strings of data about an obscure object or action and to gather them in large to make insights about a multitude of things ranging from weather patterns to even human behavior. What's even more amazing is the big data infrastructure. What's going on behind the scenes that makes the entire big data process possible?
Big data is composed of many hardware and softwares working in conjunction to make the entire process possible. Without this infrastructure, big data wouldn't even be a thing. We're attempting to eliminate some of the complexity behind big data by breaking down the phases and what powers them. So we've separated the entire process into 4 layers, in which we'll explore the hardware and software for each.
The first phase we'll be looking at is the data collection phase. To even form big data, we need to gather it first. This data can be gathered from a wide variety of sources, ranging from sales records or feedback to application usage info. There are a few pieces of hardware that can be used for sourcing this data. For example, sensors can be used to capture the data. They may be found on things like vehicles or phones and can be used to do things like detect the proximity of nearby objects or to track the number of steps a person has walked.
Data generation applications are also used, and they range from purchasing apps that generate data to show buying habits to things like YouTube, where they may utilize third-party cookies to find viewing trends. Beacons are another method of collecting data. They are scanners used to detect nearby mobile phones which they interact with to send and receive data.
The second phase is the big data storage phase. As the scope of big data can be quite massive, the need for storage solutions is quite pressing. Fortunately, physical data warehouses are a great answer to this. They are centralized repositories of data which are analyzed to make decisions, and their data is sourced from transaction systems and relational databases.
Cloud storage is also a great answer to the storage problem. It's a service model in which data is stored, managed, and maintained remotely, but accessible to users over a network. Industry favorites include Amazon Web Services, Microsoft Azure, and Google Cloud. And if big data is only be used on a small scale, like for a local business, a physical hard drive will do the trick. They can be found in large capacities for affordable prices.
This stored data is going to need to be inspected, cleaned, transformed, and modeled before it'll be of any use to us. This is where the data analysis comes in. Software for data analysis exists to ease that burden. Just feed them data, and they'll do the heavy lifting, such as highlighting important insights or suggesting actions.
Google's BigQuery allows data users to easily compare queries against vast data sets, and Microsoft HD Insight makes it fast, easy, and affordable to process larger amounts of data. It's also compatible with frameworks such as Hadoop, Apache Spark, and LLAP.
After analysis comes our last phase, data output. These insights are ready to be passed on to the critical decision makers, but these people don't have the time to search through mountains of data. Luckily, software solutions are in place to make data properly presentable and easy to read.
Management dashboards are a great choice for data output. They allow users to easily transition from one data model to another without losing any of the important data like metrics or sales figures. They do this by providing models such as charts and graphs. Great choices include Scoro, DataPine, and Tableau. Word clouds are also a great choice if you're working on a smaller scale and the data is text-based. They offer a visualization format to highlight important data points by making a specific word appear larger the more often it's found in that data. All in all, there's a lot of hardware and software working behind the scenes of big data, but it's not as complex as it may seem.
After this project, the two of us realized how large of an impact big data can have on the world. The ability to give a machine some sort of predictive capability is beyond us. Although the two of us are college IST majors, specifically interested in cybersecurity, big data has captivated us, and not just the hardware and software behind it, but the security too. Maybe in the future, we'll be looking to be working as security engineers in a field revolving around it.